Next, we get to these four instructions, which are exactly the opposite of the above instruction, just the source and destination changes. So here STAXB, just change this place. It would be from BC, from A or A register to a memory cell which BC is pointing to. The next one would be from A to a memory cell which DE on the address bus would select that memory cell. Then the last one, STAADDR, would be again from A register to a memory cell which would be selected by the address that the programmer provides as part of the instruction. And the third one would be from HL register pair. You see, it is unlike the a lot of instructions like move M and something that we said the HL register pair would select a memory cell. Here it's not the case. The HL content would go to the to a memory cell which would be selected by the address that the programmer provides as part of this 3-byte instruction. All the other things would be the same. You see, just like this. Also pay attention to this, that this was from a memory cell selected by the address from the programmer to the HL register pair. Just be careful for when the HL is an address and when it is data. And also this would be just 1 byte, just like the above, 1 byte, 1 byte, 3 byte, 3 and 3 byte. And the fetches, well, the opcode first of all would be 00000010, because this is 00, this is 01, 10, and 11. So the value here would be 02. Then this would be obviously 12, 22, and 32 would be the opcode of all of them, and everything in hex. And finally, the machine cycles or different steps. And pay attention that only the read would change to a write, because we said when the data when the CPU moves data from itself to another place, it is writing to the memory. So the first one would be a fetch to fetch the opcode, which is 2H or 02 in hex, or this value in binary, and one write step to write the data from A to the location that BC has selected. Next one would be also the same, fetch and write. Next one would be, well, one fetch, right? One fetch to fetch the opcode. Let me change the color. One fetch to fetch the opcode, one read to read part of the address, another read to read all the 16 bits, then one write to write the lower byte to the L register, to write the contents of the L register to one of the memory locations, and exactly it would be like before, lower byte, lower address, higher byte, higher address, and finally the last write from H register to the higher address. F, R, R, W, W, only the last two R would be different. And here also we would have one fetch, then two read to read the address and to put it on the address bus to select a memory cell, and writing the value in the A to the memory cell which has been selected by putting these the result of these two read, which would be this address, on the address bus. So it would have one write. This is this group. And finally the last instruction in the transfer, you see the opcode doesn't have any X because it is just one single instruction. In hex this is equal to E and B. EB in hex or this in binary is the opcode of XCHG, and as the name suggests, it's exchange, meaning it is exchanging the value of the HL register pair with the DE register pair. And obviously because we don't need, the CPU doesn't need either to read from the memory or write to it, doesn't need to do any one of them. Everything is done inside the CPU. So the moment it fetches the instruction, it would accomplishes this instruction in the same step or machine cycle. You would see later that normal fetches or almost all fetches in 8085 are done in 4 clock cycles. This fetch is done in 6 clock cycles, meaning that each instruction is made up of several steps or several machine cycles. Every machine cycle itself is made up of several steps or several clock cycles. We just choose different names and we see that even though the step or machine cycle for this is 1, but the clock cycles of this fetch is a bit more than the normal ones. So these were all the 8085 microprocessor instructions, and if you want to summarize, all these transfer instructions are either byte from register or byte from memory. Pay attention, then when I say byte from memory, it's this instruction, move I m byte. It's byte to the memory that has been selected using the HL register pair. Then from register to register, register to memory, and memory to registers. Then about 64 of these instructions, the opcode is so easy, 0, 1, and with this format. And with these 8 other 72 of these instructions, this table is used. So remembering these 72 instructions out of the 85, remembering their opcode, even though it's not necessary, but it's easier. And then we have these other 13 instructions used for other transferring instructions. And finally, this is another kind of summarizing all the different instructions based on their addressing mode, their instruction length, and their steps to take for the instruction to get executed, which we call the machine cycles. This was a summary of all the instructions in the transfer mode. In the next lecture, we are going to actually look how these instructions get executed inside the CPU. What is the underlying hardware inside the CPU which could just transfer data between different registers.